we have the welcome, which is right now. So I hope everyone had a good day so far. We will then jump into the introduction. What is ASAM and what is ASAM all about? Unfortunately, Peter Voss has no time today, so Dorothy, our marketing manager, will jump in and present what ASAM is all about and what we do and what we don't do. Then this will be followed by the introduction of ASAM OpenDRIVE. I will present that to all of you so everyone has an overview what the ASAM OpenDRIVE standard is all about. Then we will jump into the transportation module of CityGML. Christoph Ball from the Technical University of Munich will give a presentation on this one. And then we nearly have 1.5 hours passed, so that is time for a coffee break so everyone can get a refresh. And then Andreas Richter from Volkswagen will explain the area model that we developed during the OpenDRIVE concept paper project, and where he was leading the working group to develop that topic. And then we will have the proposal presentation. So Andreas and Christoph and Roland worked on the proposal for that project, and they will present to us what they came up with. And then we will have an open discussion on that project proposal, and hopefully we will have a few good ideas and hopefully a lot of interested parties to join that project. And then, of course, in the end, we will plan the next steps and what are the important things we need to consider when starting the project and what do we need to do in order to get the project approved by the ASAM TSC. And that will be it then. Depending on how long the discussions and the Q&A sessions are, we will end at 5 p.m. CET or earlier. Perfect. Are there any questions beforehand? Otherwise, I would hand over to you, Dorothee, to start with the introduction of ASAM.
Yes, hello everybody. I'm Dorothy Basserman. I'm the marketing manager at ASAM. Let me share my screen quickly. 1 second.
Yes, we can see.
So you can see it. Good. Yes, again, hello everybody. Great to have you here today. I have the honor of replacing Mr. Voss and introducing ASAM. I try to make it quick so you can go straight to business and to what's really important. Nevertheless, I think there are a couple people who don't know ASAM yet, and that's why I'm introducing us again. We are non-profit. We are a standardization organization for the automotive industry. And we focus on implementation level standards. That means we don't have any process standards defining processes and so on. It's more like a hands-on standard for implementations, formats, APIs, things like that. Important to know is ASAM standards are just recommendations. They do not have an impact on regulatory framework. That's very important. You don't have to obey to our standards. It's just a recommendation. They are developed in working groups, which are open and non-competitive, meaning everybody can take part. You have to be ASAM member, but no matter if you're OEM or a tool vendor or academic, everybody who's a member can take part and work on non-competitive issues and areas. Another important point here is we are membership driven. That means that everything that's done within ASAM comes from the ASAM membership. It's an idea from the ASAM membership. All requirements come from the ASAM membership. We are just the frame around it, basically, and the legal owner of the standards later on. But other than that, we are very membership driven. About our organization, I want to introduce to you our board of directors. It is chaired by Mr. Rika from Horiba. We have an OEM Mr. Großpietsch, BMW, Mr. Köster from DLR, Mr. Nuremberg from HiQsoft, and Mr. Rupala from RA Consulting. So it's a good mixture of OEM, of tool vendor, of service provider, and research. And I think this is a round picture, so we have all our member groups in mind. Let me tell you something about our membership, how it has developed within the past years. You can see we had a big jump here as of 2019, and later we had a lot of a big member growth. That was because in 2018 we took over the OpenX standards, which formed the simulation domain. And we started work in 2019, basically. It started end of 2018, but in 2019 it really picked up, and you can see that in the member numbers here. In 2019 we gained 75, 1 year later 77 new members, and still last year 52. So not all, but quite a few are especially for that area where we didn't have an expertise before, but now I really can say we have a great expertise here. Within our membership, of course. And if you have a look at the overall community, it's very, very big. Many OEMs, many tier 1 suppliers, but and many tool vendors, but also universities, research institutes. It's all as a whole the ASAM membership. More than 370 member organizations, we must say. And this gives you an overview on how the new members, where they come from. As you can see, they are still mainly from Europe, but also China or Japan are picking up, and rest of Asia, Korea, for example, India. So we have lots of new members there as well. And also in North America, we have Polaris and Canoo as new OEMs. In Europe, by the way, Renault just joined ASAM. And yeah. So I think we are representing a large share of the ASAM automotive, industry. On this picture, you can see our standards. I mentioned earlier the simulation domain. This is also what the proposal workshop today is about. The ASAM OpenX standards. Whenever you hear ASAM and open, it's usually an ASAM standard. Yeah, right now we have 5 real standards in that domain. We have more activities, but not yet standards. We hope they will become standards soon. Oh, they will, they do. Yeah, but this is only one domain. Since 1998, we have been very active in the domains measurement and calibration, diagnostics, ECU networks, software development, test automation, and data management and analysis. And these standards have been developed, as I said, since 1998 and even before. And right now they are quite mature and well accepted in the industry, in their areas or their domains. And the OpenX standards become also more and more mature and are well adapted. Yeah, the ASAM development. We have several phases concerning the development. I do not want to go into detail here. I think more important for you is here the right side. Again, our principles, what's important for us for standardization within ASAM. Again, here member-driven. Yeah, initiatives are coming from the membership. Decisions are taken by the members, not by ASAM, usually, unless it's a strategic issue. Yeah, then of course the ASAM board comes into play and also the technical steering committee, but usually everything is driven by the members. Yeah, we foster an open exchange, and we actually request an open exchange because we think that only this way we can consider all the requirements and everything that's necessary to make the standard really usable for all stakeholders. Domain expertise. That is what members bring back to us, that the expertise within ASAM is great. People who work in work groups are always, they really like the expertise that's there, the networking that's going on. So that is a very important point at ASAM, and we need this expertise, obviously, to develop standards that are useful for you. Our processes are pretty flexible. We do have rules and requirements for our project work, but it shows that our development times are rather shorter than in other organizations, standardization organizations. And we really try to be flexible, and whenever a work group is deciding on something, we really take this into consideration, or usually follow that step, and only if it's really necessary. As I said, we do have regulations and rules here, then we might step in, but usually we are rather flexible. And project support, that's also important. The project support is provided by ASAM with our technology managers. In this case, for example, Nico is in charge of OpenDRIVE, and he will support, once a work group will establish eventually, then he will support that group, but we also provide the projects with budgets for service providers, a certain amount of budget. So that's also an advantage of ASAM. And if you have not yet been involved in ASAM, this is a chart where you can see what you can do. And here on the left side, there are things you can do without an ASAM membership. And for some things, you need to become ASAM member here on the right. But the first thing I recommend, if you're interested in ASAM standards, in ASAM standardization, go to our website, check it out regularly, see if there are events coming up, check out our newsletter, read it, stay informed, but also network. If you come to our workshops, there will be experts that you can network with. Unfortunately, right now, we cannot have any face-to-face meetings, but hopefully if this picks up, then really join us on site and see what's going on here at ASAM. Next point, ideation. You do not have to be an ASAM member to bring up an idea and come with a proposal to ASAM. We will try to find other companies who have the same problem, who have the same challenges, and who might be interested in joining this initiative. But you do have to become ASAM member once the project group starts. Proposal workshops like today are still open for everybody, no membership required. Participation in the project, so if this becomes a project, will require ASAM membership. But you have time to decide whether this is important for you or not. The advantage here is you can give feedback. You have the possibility to really shape that standard, to develop it and according to your needs and your requirements. And later on, to get even more insights into ASAM, leading a project is a great opportunity. And last but not least, you can also take part in the Gremia work at ASAM. Be a part of the board of directors or the technical steering committee, and that really gives you an overview of all in ASAM and all the activities, everything, and you really have the possibility to make a difference, to do something. As a matter of fact, I would like to let you know the TSC elections are coming up this year on March 23rd. We have the General Assembly. And all ASAM members, if you are interested in running for the TSC, please check out the website. There you find a form for an application for the Technical Steering Committee. I invite you, please fill it out and send it to us, and that would be great. So, yeah, here. This is a reminder, General Assembly. It is conducted together with a technical seminar this year. So the General Assembly is on March 23rd in the morning. And in the afternoon and morning of the 24th will be the technical seminar. Yeah, the General Assembly, basically it reports about all ASAM activities on a strategic and business level. And we have the elections, like every 2 years, we have a TSC election, alternatively a board election. And the ASAM technical seminar goes more into detail into specific project. It informs you about the latest releases, new projects, other topics, technical topics that are currently hot. Yeah, it gives you definitely an excellent overview on the current ASAM activities, and the technical seminar is also for non-members. The General Assembly is only for members. Technical seminar for non-members, I invite all of you register on our website. When we send out the document, here's a link to it. And another announcement, every 2 years we have the ASAM International Conference. The last conference was in 2019. Unfortunately, we couldn't have the conference last year because of Corona. This is why we are pushing it to this year in November 29th and 30th. If you have been there in 2019, it was a great event, I think, for all of us. I can really highly recommend to join us there. Take part in the conference. Networking was great, and you can also exhibit. So this is just a teaser because it's not online yet, but the call for presentations will come out next week. If you haven't subscribed to our newsletter, do so. So you will be informed about the call for papers, about the exact dates and program of the international conference and all the other events as well. So yeah, that was it from my side. Thank you very much. I hope I wasn't too long. I don't want to take too much time from your workshop. And I hand over to you, Nico.
Thank you very much. That was a great insight. And I also shared the link to the TSC election on the ASAM website in the chat. So if you're interested in that, just click here and you'll be directly forwarded. But just after the workshop, of course. Okay, perfect. So if we have a look at the agenda again, I will now jump into the introduction of ASAM OpenDRIVE and tell you a little bit about what OpenDRIVE actually is. So that will be a rough overview. I don't want to go into too much detail. So give me a moment, I will share the slides. And we will have a Q&A session afterwards. So yeah. So just as the first overview, these are all the standard initiatives and standard path we have in the simulation domain. So Dorothee already showed that previously. Here I've included also the initiatives that are not standards yet, like OpenODD, OpenX ontology, and the study project test specification, where there might be a few projects coming out of it. And we'll see what they bring for us. Then, for example, OpenScenario has two streams right now, the OpenScenario 1.x using an XML-based format similar to OpenDRIVE, and then OpenScenario 2.0, which is currently in the release candidate phase and is waiting for review and feedback, and will be a scenario description language. Yes, so this is pretty much the current overview of the simulation domain. And just to emphasize on what it means to develop an ASAM standards, OpenLabel, I think, is a good example. So we had the first ideation workshop for OpenLabel back in 2019 in November. And in 2021 in November, we were able to release the first OpenLabel standard. So we went from the concept paper through the standardization within 2 years. And I think that's a good benchmark. So, but now, as promised, I will now jump into what is OpenDRIVE and what is it all about. So OpenDRIVE Now there's audio in the background for these slides, so that's not supposed to happen. Let me reshare that real quick. So here we go. Okay. Okay. So OpenDRIVE is an exchange format for defining road networks. And the basic and most important concept within OpenDRIVE is the reference line, which you can see right here. And pretty much everything else is attached around that reference line. So we can attach lanes to that. So the reference line spans its own coordinate system, the S&T coordinate system. And then all the roads that are defined with the reference line are living in a bigger Cartesian coordinate system. And of course, what we will also attach to the reference line are speed limit signs and other features like traffic islands and stuff like that. So this is pretty much the basic hierarchy of OpenDRIVE files. If we look at a very simple example of a T-junction, then how would that look like in an OpenDRIVE file? So we would need to define for the individual roads of the junction our reference lines. So we can see them here right now. And then obviously for all the paths within the junction, we will also have connecting roads, and that would be those. And they are overlapping.
Screen
Yes?
sharing is currently not working.
Screen sharing is not working. That's very bad. Thank you, Andreas. Working now?
Yes. Yeah. Way
Okay,
more
perfect.
better.
Perfect. So this is pretty much now the image to the audio you've just heard. So let me recapture here the reference lines for the incoming roads into the junction. And here you can see the connecting roads within the junctions and their reference lines, and they're obviously overlapping. And now let's add the lanes to the individual reference lines to make up that road network. And here you can now see the connecting roads. And what you might guess is that the junction modeling in the current OpenDRIVE approach is quite challenging to cover the whole area, which works here quite fine because this is an oversimplified example, but in real world examples, that is quite tricky. So yeah, and so we have here 3 incoming roads and 3 connecting roads, so 6 roads in total just for this example. And then obviously what we could also do is place objects along the roads to make up a valid road network. So for this example, we have this speed limit signal, we have a pedestrian crossing, we have street lamps and objects we can place around. We can place vegetation, but just very roughly. So you could specify the outline and reference a external 3D object. And we can specify traffic lights. What's important that OpenDRIVE lets you only reference a controller, which is then external to OpenDRIVE. Yeah, and then we can specify a zebra crossing and interface to OpenCRG if we want to model high detailed speed bumps and place them as patches on the road. So these are the capabilities OpenDRIVE brings you. And sometimes PowerPoint doesn't like me. Now you probably can't see again. Okay, so on the top level, we have the OpenDRIVE node in the XML format. Then we have the header, which will just give you basic information on what version you're using. Then we have the plan view, which gives you the bird's eye perspective of each road, including the geometry. Then we have elevation and lateral profiles that let you shape and tilt the road. Then we have the lanes, which are defined for every road. And then we can place objects and signals on each road. If we want to place controllers for traffic lights, we can do so as well. And then we have the junction node, which will then set up the connections after we designed and defined all of our roads. And then we can connect junction groups. We can connect junctions together to junction groups to form, for example, roundabouts, which we could assume are just a circular collection of T-junctions. And this is the very rough overview of the XML structure of OpenDRIVE. And if we see, and what I said before is the basic concepts of the reference line that the reference line is the basic concept of OpenDRIVE. And these are the options we have to model the reference line. So we can use straight lines, we can use spirals, which have a starting curvature and a linear change to a goal or a target curvature. And we have arcs with a constant curvature, or we can use cubic polynomials or parametric cubic polynomials. And obviously, when you look at the turn angle of a steering wheel, if you drive down those pieces of reference line, then a straight line would obviously cause no change in steering angle, while the spiral would be the part when you start turning into a curve. And arcs are just, holding the steering wheel at a certain angle. And then the polynomials are when there's a function over time on how the steering wheel angle changes. All the attributes we have for the reference line are rather simple. So we have a S position, X, Y position in the overall inertial coordinate system, a heading and a length. Oh, that is doubled in here. Yeah, so, and if we want to design a road, we can do so and we can specify length. Okay. Anyway, so we can do so and specify length and an ID for each road. And each road will have its own reference line pieced together out of the previous pieces. And then we have a type. The plan view will contain the reference line, the elevation profile, the lateral profile, the lanes, the objects, the surface information if we want to use OpenCRG, which is optional. And then we have our road. If we want to link roads together, we can do so as well using the link attribute. So we have a predecessor element and a successor element. And obviously we could do so in there as well, but using a junction as a predecessor or as a successor, depending. And just, linking up the whole junction element. And if we now jump into how we would model junctions in OpenDRIVE, and that is, as I said before, just a very, very rough overview. And as an example, we'll take that very simple cross junction we have here. So then first of all, we need to define all the roads for the junction. And in that example, these are 16 roads we need for a simple cross junction. And we need all the connections to form that junction. So as I said, define all the roads, then specify if that road is part of the junction, and then establish all the connections between the incoming roads and the connecting roads within the junction. So let's do so. So when we identify all the incoming roads, then we have the road with the ID 13 is incoming, the 1, the 0, and 6. And when we establish all the connections, then we can see here how that would look like. And now we can see that the OpenDRIVE file will give us all the connections we have. And we need to establish that junction. So how do the connecting roads then look like? So we have, let's take that simple example of road ID 2, where we have what I said before, the primitives of the reference line, specified here the line, the spiral, so straight into the curve, then changing curvature, and then jumping into the arc, and then out of the curve again with a spiral, and then back to a line. And we start, and so we have a starting point and an end point somewhere in our inertial coordinate system. Yes, and obviously we have lanes because we need something to drive on. So you can see here we have a driving lane, then we have a border lane, and we have a sidewalk. And that will be a very important road within the junction. So we can have several, so we have several of those roads, and they are all shaped differently, obviously, pointing into different directions to form that junction. So when we now look at all the junctions that we want to have or we need in our junction, so all the roads, then we have the road ID2, what we just modeled before. So you can see we have the driving lane, the border, and then the sidewalk. The grass was not modeled in OpenDRIVE, but we could do if needed. So, and then we have all the roads to model the sidewalks and the borders of the junction. And if you now think of what these roads modeled within the junction, you would see that the middle between all of those roads would still be empty. But the junction is, and there are more roads in there. It's not empty there, so we have further roads going over that patch. And how would that look like? Here we go. So now we can see that when you drive into the junction from road with the ID 6, you have 3 ways where you can go. You can go straight, left, or right. And same goes for all of the other parts of that junction, all the other incoming roads. And if you, for example, wouldn't allow incoming traffic from road ID 0 and that piece, and there would be no connecting road covering that patch, then this would be an empty patch within OpenDRIVE. And we are currently working on fixing that in the current OpenDRIVE 1.8 development, based on a concept we developed back in 2020 in the OpenDRIVE concept paper. But luckily, our junction here has roads covering all of those pieces. And this is the last picture on how a junction, a simple cross junction in OpenDRIVE would look like. A whole bunch of overlapping connecting roads in a junction. One of the challenges here is if you want to model a tilted junction surface, then you have to adjust all of the surfaces of each and every connecting road within OpenDRIVE, which is quite difficult. And hopefully we can fix this in the future. But for now, that's how it works. And that was the very quick and rough overview of OpenDRIVE. And now we can jump into the Q&A session. Are there questions towards OpenDRIVE? Thank you, Marius. We can assign a global CRG instead to the whole junction area. I've seen Esther in the call as well. Maybe you want to comment on that because I haven't seen that been done yet.
Sorry, I had to unmute myself. Yeah, you can use a global OpenCRG. It has been done for measured junctions. That OpenCRG was created for that. For OpenDRIVE 1.8 currently, we are looking at a different solution for this. Because it's quite a lot of hard work to do, basically. But yes, that's the current way of solving it, is by using a global OpenCRG that you assign to the junction.
Oh, okay. Thank you. Then we have one raised hand by Hugo Beck. We can't hear you yet, so I think you have to unmute. Still can't hear you. Maybe you can post a question in the chat and then we can answer it. Are there further questions towards that very rough and quick overview of OpenDRIVE? So the question was, what is the definition of a road in OpenDRIVE? And I think the question goes more towards, or if I interpret it correctly, you don't just want to know what the definition of how that would look like in XML, right? But more towards the terminology. Is that correct? Because if we look at the definition within the XML, then so not like communities. So you mean the different types of roads, like highways, urban roads, city roads, stuff like that? Because we can define the different type of the road, and there's a exhaustive list in the UML model and the standard on what type of roads you could specify. So if I wrote, how does a road start and end? So what you specify is a starting position in the S coordinate system and a maximum length. And once you've passed that length on the S coordinate system now, then you know your road has ended.
Quite often the road basically goes from junction to junction.
Yes.
It doesn't have to be, you could cut it in between, but at the latest when it comes to a junction, you will have to cut the road basically. So it's often from one junction to the other.
Okay, perfect. Are there further questions towards OpenDRIVE? Okay, perfect. Then I will hand over to Christoph from the Technical University of Munich to present the transportation module of CityGML 3.0.
Yeah, great. Thank you very much. I hope you can hear me, and I will try and share my screen. I hope you can see the slides. And please interrupt me anytime if the slide shouldn't be visible or anything. Just let me know. Okay, yeah, thank you very much, Nico, and thank you very much for the opportunity today to give this presentation. My name is Christoph Beil. I'm a researcher at the Tom Chair of Geoinformatics. focusing on street space modeling in the context of semantic 3D city models. And today I want to introduce to you the CityGML standard and especially the CityGML3 transportation module within the standard. First, when we go to the next slide, let's have a brief overview and introduction to CityGML in general. CityGML is an international standard issued by the Open Geospatial Consortium, and it is based on the geography markup language. This means that GIS-related open source tools are available to manage and handle this kind of data. There's also support for standardized web services, such as web feature services for CityGML. And CityGML in general is most commonly used for the modeling, exchange and storage of semantic 3D city models. So for example, all buildings in Germany are modeled as CityGML LOD2 building models and are available for the whole country, for example. Some of the key strengths of CityGML are that the data is geo-referenced. It uses 3D geometries. There's topological information as well as rich semantic capabilities within CityGML. It is possible to model time-dependent properties, and it's fairly easy to derive nice visualizations also from CityGML data, as you can see on the screenshot, which was CityGML data, LOD2 building models imported to the Unreal Engine, for example. So CityGML is generally able to handle large-scale models, for example, entire city models. And this can be managed, for example, using geodatabases, for example, the open source 3D city database, which is able to do spatial queries or semantic queries on the data. And CityGML version 3.0 was just published last year in September. And following the link on the slide, you can find the standard document, which is available on the OGC website. A brief overview of CityGML. It uses a modular approach. So there's a core module of CityGML, which defines all the basic concepts. Then there are extension modules defining specific additional concepts for all the thematic modules, such as appearance, how to handle texture, and so on. And then there are several thematic modules covering specific thematic fields of a 3D city model, such as buildings. There's a own module for how to model buildings, for example, as well as vegetation, city furniture, and so on. And especially what I want to focus on today, the transportation module, which defines elaborate concepts on how to model transportation infrastructure within 3D city models. CityGML also uses a hierarchical approach of modeling objects. So each real-world object is decomposed into smaller objects, which again can be decomposed into even smaller objects. So in this simple example, you can see a building, which is decomposed into building parts, which again can consist of roof surfaces, wall surfaces, and so on. And each of the wall surfaces, for example, could again contain doors, windows, and so on. So each of these semantic objects is modeled based on the ISO 19109 series and can be represented using different geometries based on the ISO 19107 series. So in this example, a roof surface could, for example, be modeled by a composite surface or by a polygon. And this system applies to all the thematic modules, also the transportation system, or the transportation module, rather. And that's what I want to focus on today, the CityGML3 transportation module, because in comparison to CityGML 2.0, there have been some revised and extended concepts. And I want to illustrate all of these, or the most important of these concepts today. Of course, they are also formally specified using UML diagrams, so you can look them up in the standard document itself. But for this presentation today, just as Nico, I tried to have a visual representation of all of these concepts in order to make them understandably or easier to understand. So let's have first a look at the semantic modeling concepts of the CityGML3 transportation module. And that's maybe the first difference to OpenDRIVE. Here, a road object is defined for an entire road, for example, the entire Arzestraße. So the name of the road would be the relevant attribute, for example. So everything covered in red here would be part of one road object in CityGML. At the same time, here you can see that it's possible for another road object, in this case the Gabelsberger Straße, to intersect the first road object we saw. So everything covered in yellow here would be part of another road object, which again leads to this hierarchical decomposition strategy. Both roads can now be segmented into individual sections and intersections. Intersections here depicted in blue would be used to model parts that are part of multiple roads at the same time, while sections here in orange would be assignable to one individual road alone. And CityGML also contains linking strategies, which allows this intersection to be modeled only once, but have reference to multiple roads. So it is indicated that one intersection can be part of multiple roads at the same time, while having to represent only one geometry. And loosely, this would correspond to what a junction is defined in OpenDRIVE. These sections and intersections can be further segmented into individual traffic spaces and auxiliary traffic spaces. Traffic spaces are used to model the space where the traffic actually takes place. Auxiliary traffic spaces are used for spaces in the context of a transportation network, but that are not intended for traffic movement. For example, here in the middle screenshot, you can see these green areas, which would be corresponding to auxiliary traffic spaces. And traffic spaces and auxiliary traffic spaces have ground surfaces, and these ground surfaces then would be modeled as so-called traffic areas. As you can see on the left in blue, these volumetric spaces of the traffic would be represented using traffic spaces, and the bounding ground surfaces would be called traffic areas. And each of these traffic space and traffic area would contain several function or class attributes indicating the individual function of each individual traffic area. So sidewalks, driving lanes, footpaths, cyclepaths, and so on. There are 3 levels of granularity available in CityGML. So a section in this case, in the highest level of granularity called area, would be represented with one single object for the entire width of this road or this street section in this case. The next level of granularity is called way, where there's one individual traffic space for each traffic type. So in this case, you can see the entire width of the carriageway, for example, would be modeled with a single object depicted in blue in this example. And in the highest level of granularity, then there are individual lanes that are represented with an individual object for each individual lane. Okay, this was the basic overview on the most important semantic concepts, how the street space and street networks are decomposed into smaller objects in CityGML. Now let's have a look at geometric representations, how these can be modeled geometrically. As I said, CityGML is based on the ISO 19107 series and thus uses the specified geometries that are available there. And the 2 most important geometries, probably in the context of the transportation module, are on the one hand side multi-curve geometries and on the other side multi-surface geometries. So it is possible to model these objects with aerial or surface-based representations as well as with linear or graph-based representation. This is fully supported by GIS spatial databases. Nearly all geometries use 3D coordinates, and in CityGML, each coordinate must be given with respect to a specific coordinate reference system. It's also possible to have objects in a local 3D Cartesian coordinate system, which is important when you want to integrate BIM or CAD data into your scene. Okay, let's have a look at a simple example of a city model with a CityGML building here, CityGML vegetation objects, and CityGML traffic areas here depicted in different colors with respect to their different function attribute. As I mentioned before, it is possible to model this scene in CityGML also using traffic spaces, and there are different geometries available for modeling traffic spaces. In this example, you can see the volumetric representation of these spaces, but it is also possible to use linear geometries or even point clouds to represent these spaces. In this case, this volumetric representation, for example, could be beneficial or could be used for a potential conflict analysis in combination with vegetation objects. So you can see where vegetation objects might interfere with traffic spaces, for example. This is the same representation to show you that each of these traffic spaces also contains a number of semantic attributes, for example, its function, its usage, its height, its ground surface, and so on. And the same traffic space, as I mentioned before, could also be modeled as the ground surface, so the traffic area in this example, with the same attributes, basically. And as I mentioned before, traffic spaces can also be represented using linear geometries. So this would be a very basic and simple translation of the example I showed before with the volumetric representation and the aerial representation in a linear representation. So depending on the application or the available data, it is possible to model the same object using different geometries. Coming back to this level of granularity concept, you can see here a simple intersection with an example of an aerial representation on the left and a linear or graph-based representation on the right for the highest level of granularity area, where, as mentioned before, you would model the entire width of the street using one object in the aerial representation, or basically the street center line in the linear or graph-based representation. Granularity way, then, this would be further divided into one traffic space per traffic type, for example. So you would have one traffic space for the entire carriageway width and additional traffic space objects or traffic area objects for the sidewalks, for example. And the same would be true for the linear or graph-based representation, where there would be an individual linear network for the street network and also for the pedestrian network. And in the highest level of granularity, then, each object would be represented on a lane level, so to say, which is again true for the aerial or surface representation as well as in the graph-based or linear representation. Okay, these were the most important geometric concepts of CityGML. Now let's have a quick look at topological concepts that are provided by CityGML. One concept that is new in CityGML 3 is the possibility to have information on predecessors and successors for traffic spaces. So in this example here, you can see a linear representation of a very simple three-way intersection in granularity area, because it's the center line for each of these street sections, basically. And each of these sections would contain information on their respective predecessor and their respective successor. Another concept that is available in CityGML is called, for example, in the GML encoding, would be called X-links. So there's a linking mechanism which allows you to link one specific object or one specific geometry to multiple other objects. In this example here on the right, you can see a building with a small garage next to it. And so the building, the main building and the garage would share a common wall. This wall does not have to be represented twice, but only once explicitly as a geometry, and could be linked to the other object that shares that geometry via this X-link mechanism, for example. And this mechanism, the same concept would also apply to intersections, for example, that could be part of multiple roads, as I described in the very first example before. Then in city models, it's often the case that there are not just roads existing for themselves, but often they directly interact with other transportation infrastructure. So for example, you can see here an example of tram lines or railways that directly interact with road objects. And since the concepts I showed to you do not only apply to road objects, but there are also railway objects or even waterway objects available in CityGML, these different types of traffic can be combined in a combined and non-redundant representation using the same semantic and geometric concepts to model this scene. And this is important to have a consistent and integrated and also standardized way for an entire 3D city model to be modeled, which can be relevant for several applications, as I hope to show you later on. A very basic example here, you can see one road crossing a railway object. The road would be split into a section A, a section B, and this intersection part called E in this example. The railway object in this case would consist of a section C in blue on the left and a section D on the right, and also be linked to the intersection object E. This means intersection E would only have to be represented once, would have the information that it is part of a road at the same time as it is part of a railway, for example. And again, each of the sections and intersections can be further split into individual traffic spaces, which can be bound to the ground with individual traffic areas, for example. And using multiple function attributes in this intersection area, for example, it could be indicated that one specific traffic space is part of a driving lane at the same time as it is part of a railway lane, for example. There are also concepts for linking different types of infrastructure. So it is also possible to have transportation objects within building objects, for example. So in this case, on the left, you can see here a parking garage, which would be commonly modeled in CityGML as a building object with wall surfaces, roof surfaces, as I showed you at the beginning. But at the same time, the transportation part of this building, so the traffic surfaces, basically the traffic areas within the building, could still be modeled, and again would only have to be modeled once, but could have relations to different kind of top-level features, so to a building object at the same time and a road object simultaneously, basically. Then there's the possibility to model squares, so-called squares in CityGML, which is used for large sealed surfaces. So on the left-hand side, you can see an example of a parking lot within a city model, and on the right-hand side, you can see a public space, which also would be modeled as a square. Here, there's no intersection concept, but again, squares could be further segmented into individual traffic spaces, for example, really individual parking lots within this big parking lot, for example. Then there's a class called marking, which is independently used and can be used to model markings, surprisingly, and again with individual function attributes such as a stop line, arrow straight right, or arrow left in this example. Each of the marking objects could have further attributes attached to them, which indicate their function in this case, for example. Then there's a class called holes in CityGML. This could be used for holes in the surface of a traffic area, for example. And in this example here, you can see a drain, but this could also be used to model roadway damages, for example. Another quick mention I want to make for CityGML is the possibility to extend CityGML. So CityGML has a built-in mechanism, which is called application domain extension, which allows you to augment the data model that is available, and you can add concepts to CityGML that are not directly available. So the advantage of this is that this extension then would be formally specified, and there are a number of examples for CityGML application domain extensions. For example, the energy ADE, noise ADE, utility network ADE. And this would also be a potential for the future to think about a potential CityGML OpenDRIVE IDE, because there are some concepts not available in CityGML, which OpenDRIVE highly depends on, for example, parameterization or linear referencing. And maybe this could be integrated into a kind of application domain extension to CityGML. For the final slides of my presentation, I want to give you some demos and examples of semantic 3D city models and street space model in particular. So this example is a rather complex intersection in Ingolstadt, which was originally gathered as OpenDRIVE data. And at our chair, my colleague Benedikt Schwab created and implemented a converter, which is able to convert OpenDRIVE data to CityGML. And you can see the result of this conversion process and some after post-processing in the slide. And how this basically works is that OpenDRIVE data can be converted to CityGML and then further processed into any format that, for example, FME is able to read, basically, and also to store in geodatabases. So this was the basic workflow we used here. We had OpenDRIVE data in the beginning, converted it to CityGML data using the Artron converter, further processed the data with FME, used the 3D city database then to create the visualization and also the 3D web map client I want to show you in a minute more. Maybe a quick mention on the 3D city database, which is also an open source tool to manage CityGML data, as I mentioned at the beginning. It has several components. For example, it is able to import CityGML data, obviously, but then also able to export, for example, visualization formats such as KML or GLTF. Also, there's a web feature service available, and there's the 3D city database web map client, which allows an interactive visualization of these models. And that's also what I quickly want to show to you here. So this is the same model in CityGML visualized. And as you can see, as soon as you click on individual objects, they all contain a number of semantic information. So its function, in this case, a driving lane that is also part of a crosswalk, this traffic signal or this traffic light rather, contains information, the marking contains information, and so on. So this is the basic idea of CityGML, to have accurate geometric representations, as well as rich semantics, structured using the concepts I tried to show to you today. Okay. Another quick example is this, to show you the scale that is possible. This is a street space CityGML model that is available for the entire city of New York City, for example, which was originally created from open data and which is also accessible. So the link is provided in the slide. You can have a look at this model yourself if you are interested. Okay, then I quickly want to go over one or two applications and maybe skip the first part with a look on the time, and just show you this application we did with CityGML street space data. So we used the CityGML data that was converted from OpenDRIVE to CityGML and contained information on individual sidewalks and crossings or crosswalks, for example, to derive a base map for the pedestrian simulation tool called Momentum. Then this created basically a map of surfaces that are preferably used by pedestrians, and obstacles such as buildings, vegetation objects, or traffic signs in this example. And then Momentum was able to use this information to run a pedestrian simulation with that. Another aerial representation here you can see is a solar potential, or rather a local heat island simulation we did. So in combination with CityGML building objects and CityGML vegetation objects, there's a tool which allows you to simulate basically the sun and the irradiation of the sun over the course of a year, for example. And so you could directly see effects of, for example, vegetation in a certain area on solar irradiation. So this was rather a lot to tell you in this short amount of time, but coming to the conclusion, there are, as I hope to show you, several semantic, geometric, and topologic concepts, as well as ways to visualize the data. There are concepts for the geometric and semantic segmentation. It is possible to have different geometries to represent these objects. There's this concept of spaces, as I showed you. There are different levels of granularity available and different classes, such as markings, that can be used to model the street space. It is possible to have an integrated representation for multiple transportation infrastructure, such as roads in combination with railways, for example. And I hope that it was illustrated that there are also some applications, or many applications, in the context of digital urban twins, for example, or smart cities, that could or can use this kind of information. And also, as I mentioned, there's potential for extending CityGML in the direction maybe of OpenDRIVE, and I think that is something that would be interesting and challenging to discuss in the future. So thank you very much. This was the quick and extensive explanation to CityGML. Thanks very much.
Thank you. Awesome. So we have the first question from Marius in the chat, and that would be, why is there a definition of holes specifically and not just a definition of delta geometry, which could go any direction, e.g. speed bump and a pothole at similar locations, or even a pothole with a speed bump? Or an asphalt patch with a specific surface structure, which may be a more common use case?
That's a good question. Well, that's the way it is modeled in CityGML. So CityGML is based on the surface representation, and also for many applications, it is important to have a non-overlapping and continuous surface, so that there are no gaps in between the individual objects, for example. So this is why the holes are directly integrated within the surface of, for example, a traffic line.
Okay, perfect. Thank you. Then we have another question that is, models for predicting solar irradiation and its consequence would also need detailed material models. Where could we find these?
That is also a good question. The simulation I showed to you, I think, does not until now include information on materials or reflections and so on. So, but CityGML, of course, has the ability to contain several attributes. So at least via an attribute, this information could be contained within the individual surfaces. But I'm not aware of a tool at least for CityGML data up to now, that would also use this information. But this is a valid point, of course.
Okay, perfect. Thank you. Are there further questions? You can either use the chat or raise your hand. Yeah, Andreas, you have your hand up.
Yeah, thanks for the presentation, and I'm really looking forward to work together with you about these topics. My general question here is maybe you can tell us a little bit more about the purpose of having unique traffic spaces. So you showed in the examples that the traffic space is divided into the elements where the specific amount of traffic is occurring. So one patch for road, another patch for road and pedestrians, another one for rail and pedestrians, etc., etc. I assume that there is some kind of idea behind this concept.
Yes. So the idea is to have some kind of different level of detail depending on the available data or depending on the available application. So for example, for the solar irradiation simulation, it would not be necessary to have a lane level detail with all of the individual traffic areas available, but it might be sufficient to have a surface geometry which indicates that all of the surface is part of the entire width of a road, for example. So in order to have this kind of different semantic levels, this level of granularity is introduced, but it is free to the user or to the application which level of granularity you want to use. So you don't have to represent the street space all the time in all the different level of granularities. They are just an option you can choose depending on your intended application.
Do I get it right that I could also model overlapping traffic spaces without slicing them into small mosaic stones?
So CityGML does not make a clear recommendation. It's not strictly prohibited, but I would say that for many applications in the 3D city modeling context, for example, if you want to calculate the total area of a road, or you want to do this solar irradiation simulation, for example, it would be good to have non-overlapping geometries, but it is not strictly prohibited in CityGML.
Okay.
Okay, so we have another question for Marius, and that is there a planned link to the Open Material project? Either in CityGML or in the upcoming project?
I don't think that's something we've discussed so far.
But I can tell that this is definitely a good idea. So if we are focusing on bringing the environment together with the precise road description into simulation, then definitely a material definition makes sense. And if the environment, for example, is provided by CityGML-based database, then it makes sense to think about how to add this open material concept, for example, to CityGML or something different. But this should be on the roadmap anyway. But the good question is, what is the best solution? How to link, where to include? I think these questions are still open.
Yes, and I think maybe we can discuss this later in the discussion round. We've got another question towards CityGML, that how do you match vehicle types onto lanes? For example, a bus on a bus lane. I'm
not sure if I understand the question correctly, but that would be something in the process of the data gathering. I think that would be similar to the way OpenDRIVE data is gathered, for example. I think also OpenDRIVE contains different possible traffic types for each individual lane. So I'm not quite sure if I understand the question correctly, but in the process of gathering the data, then this kind of information would have to be linked to the individual geometries.
So perhaps let me add something on this. Christoph, you told about the extension mechanism of CityGML. So in CityGML, the schema has a lightweight extension mechanism that's called generic attributes and generic objects. So
that's true.
Anything that's not modeled specifically in the core modules or in the thematic modules, can be modeled with this generic approach. The problem is with this, you have no common understanding of the semantical meaning, but you can extend, for example, a lane with arbitrary number of attributes. So there you can say, for example, lane type is bus lane or something else.
That's right. So the example attributes I showed, like function or class, they are implemented within the standard and can be used. And there are also extensive code lists which suggest a number of values for these function attribute, for example. But as Max just said, it's also possible to add generic attributes depending on what information you need within your model.
Awesome, perfect. So do we have further questions or comments on CityGML? So we're slightly ahead of time.
Yeah, one short question again from my side. So in the beginning, you said that in Germany, most of the larger towns already have an 3D city model available. Can you tell us a little bit about the coverage or the usage of CityGML in the rest of the world?
Yeah, so the CityGML building model, I think for Germany and also in other parts of the world is quite common. As I said, for Germany, the entire Germany contains a LOD2 building model, which is based on cadastral data, which means that it has the respective accuracy of better than 3 centimeters, for example. And there are also projects in Japan going on, I'm aware of, for creating a detailed city model using CityGML. I think the Netherlands are quite involved in using CityGML data. And yeah, I think there are also some lists available where you can check up individual data sets that are available for different parts of the world. And maybe in the aftermath of the meeting, I can give you a link to that if you want to.
Perfect. Thank you very much. Then we have another question: is there a process for generic attributes to make it into the standard one day? So for example, if we have something that is frequently and commonly used.
So for something that is frequently and commonly used, I think I would suggest to try to implement that using the ADE mechanism, because those are, as Max said, the two ways to extend CityGML, one quick with these generic objects, and the other a little more effort-based to have a application domain extension. And there are examples from the past where an application domain extension was created. For example, the dynamizer concept, which is used for representing dynamic properties, which is now part of the CityGML3 standard. So once there is an application domain extension available and commonly used, then there's obviously also the possibility to integrate it in the next version of the standard itself.
Okay, perfect. Thank you. And Benedict posted a list of CityGML datasets in the chat. So Thanks. Thank you very much for that. All right. So are there further questions towards CityGML?
Of course, you can reach me anytime via mail. I think the mail address is included in the slides. Thank you very much.
Then I would say we will jump into the coffee break. And we will return in 15 minutes. So that should be enough time for everyone to warm up the coffee machines at home, or a teapot or whatever you need. And we will reconvene here in 15 minutes. So let me share the agenda real quick. So to continue with the presentation of the area model by Andreas, and then the proposal presentation. And so we can then jump into the open discussion on how we want to proceed with the project and the proposed content. So then thank you, Christoph, for the intensive presentation, and thanks everyone for the good Q&A session. And then I will see you back in 14 minutes now. All right, welcome back. I hope everyone is refreshed and got a coffee, tea, a beverage. And Andreas, are you back as well?
Yeah, sure, I'm back.
Perfect.
And now
then I will hand over to you. Andreas, are you still there? Okay, I think Andreas has some technical issues, so let's give him a second for reconnecting. Maybe in the meantime, did any questions during the break arise towards OpenDRIVE or CityGML? Okay, let's then give it another 3 or 4 minutes, and hopefully then Andreas will be back with the presentation.
So hello again.
Yes, you're back.
Yeah, it seems to be that my PC was still in coffee break. Sorry for that, was not my intention. Before my computer left me alone, I shared a link. I'm not quite sure if this was shared in the chat.
No, unfortunately not.
And I will do it again. No big deal. Well, I did a presentation for this meeting, but we will have a look on that is already available, because this is the document that was generated in the OpenDRIVE.
Andreas, your audio is breaking up. Maybe you need to turn off the video.
Project. I think in the beginning of 2019, continuing to 2020, there was the OpenDRIVE concept project that dealt with some more general questions, how to solve bigger issues in OpenDRIVE. or add additional content to it. And there was also a working project that was called Area Model, where I stated that it may make sense to think about a new approach to describe road environments than we are currently doing this with OpenDRIVE. So the main idea was that we that the data we would like to have in our simulations are getting more and more complex because for example, in the automotive domain, the assistance systems are getting more complex, more functions are involved, more sensor data is used by these systems, and therefore for the development and the verification of the systems, it's necessary to have them in simulation. The simulation so that
Andreas, your connection is very bad. Maybe I can share this screen and you can just direct me where I need to head.
Okay, then let's do it this way.
Just one. Give me a second so I can share the concept paper. So here we go. So I think that was the part where you were at.
It seems to me that my connection currently is super slow. So I'm just seeing here a black screen. Okay, yeah, no. Yeah, looks familiar. So yeah, as I said, more complex data, more real world data in the simulation, and the interest of getting additional data like we had in the discussion about the materials previously, that also sensor simulation needs more information as we currently have in OpenDRIVE. Okay, audio is still bad. So I currently do not know how to tackle this.
What you could do in parallel is use the call-in number. Let me find that for you real quick. Dorothy, are you still in the call? Okay, apparently there is no call-in number. Andreas, are you still there?
I am.
Andreas, is your connection better now? I think we lost him again. Okay, so maybe once while Andreas is trying to fix his technical issues, Roland, Max, Christoph, would you like to present us the project proposal? And then we need to catch up with the area concept approaches and concepts afterwards. Would that be feasible?
Yes.
Roland, do you have any slides prepared?
No, I have no slides, but we can just go through the proposal paper, which was, I think, also delivered. So I share my screen.
Yes.
Okay, so yeah, what is this proposal all about? So if someone of the proposal team has additional information, then please jump in. Yeah, we already heard now about the OpenDRIVE and CityGML standard, and we'd also like to discuss about the area model later on then. And this proposal is about environment modeling. It's about gathering some requirements for this issue, and yeah, it's also about what do current standards, ASAM OpenDRIVE or also CityGML, what do they already provide? Do they meet all the requirements for such an approach of environment modeling? And then we want to have a look how we could possibly link existing standards, or if that's not possible, or if that's not solving the issue, how we could move on otherwise. And yeah, so the executive summary, I think, was also linked on the ASAM website. So you probably all have read this. And the overview about the current standards, I think we already had with the presentations of Nico for OpenDRIVE and also for CityGML. I don't know if we want to go.
I think the previous presentations covered that.
Yeah,
I think so too.
Perfect.
Sorry to interrupt. Hello, yeah, I'm back again. Is the audio quality at least now a little bit better?
Yes, it is.
Okay, maybe we can
give it another shot.
Regarding the,
yeah, it makes
makes
of course.
sense.
Try to share it again.
Okay, perfect. The challenges of distributed
Not quite sure
projects.
What happened here? Yeah, well, sorry for that. Welcome to the first century. Talking about OpenDRIVE.
And you're breaking up again.
I say for the whole Volkswagen group. Damn it. Watching the device. So hello again.
Yes.
Try.
Yes, works.
Perfect. Just switch the device. So I currently cannot share anymore. So
that's a solvable issue. That's a solvable issue. So now we should be able to see the concept paper. Where do you want me to jump to?
Yeah, we are right at the correct place. Motivation. So I will try to keep it short due to the lack of time. So sorry for that. Everybody can read this afterwards. So why we came up with the area concept was the issues we saw regarding getting real-world data into OpenDRIVE. So the idea was having more real-world data without having the need of creating new applications and create the environment without having gaps in between. Focus was on complex urban situations because this is currently the most challenging part automotive domain is focusing on. And as I said, we would like to reduce the amount of time you have to put in to create the complex road layouts. Another issue we had at the end is if you would like to cover a lot of mileage in OpenDRIVE, then the XML structure of the data will generate a huge load of data. So it's not really scalable if you would like to create a road network of a huge city. And you could also not include this into a simulation tool, for example. So that's why we came up with the idea of having a new approach. You can scroll down a little bit. And we tried to do it based on a complex example, like this is shown here. So as you can see, this is an intersection consisting of multiple intersections and trolley in between. So a lot of stuff is going on there. And if you go a little bit deeper, then you can see an OpenDRIVE representation created based on surveying data. And you can see here that modeling the intersections with all the overlapping lanes can get cumbersome, especially if you also have to create the inner traffic islands to fill all the gaps. to have one consistent 3D model. If you scroll to the next picture, then we see just a concept graphic how traffic area representation could look like. So the basis is the usage of a surface representation that is currently not shown here. And on top of this, there will be placed additional layers with respect to specific usage. So for example, the blue layers are used for representing the road traffic. And as you can see here, the complete surface is mentioned. There are currently no lanes. The yellow one are used for the pedestrians, the red ones are used for bicycles, and the green ones for the trolleys. And they are all overlapping. So this is like a layered approach stacked on top. And additionally on that, what you see here in purple, this is the representation of the road marks that are again on top of the road surface. Because the idea here was to model what is there and not to use some kind of artificial constructs like OpenDRIVE is doing this with the reference line. Both has advantages and disadvantages for sure. But here the idea was going a little bit closer to the real world. If my connection wouldn't be so unreliable, then I had shown you some more screenshots of cadastral data that is currently available today, because the idea here is also to make it possible to assess new data sources, for example, all the data pools that are hosted and maintained by public authorities, for example, so that you don't have to survey the complete city on your own, but you could facilitate the data that is already there, if it is good enough. So, but this is a different story. So if you can continue in the document, then there should be somewhere a table. Yeah, there it is.
Are you talking about this table?
Yes, exactly. So this again is a comparison of the concepts, the area concept and OpenDRIVE, to show a little bit the advantages and disadvantages. As I hopefully already mentioned, the methodology is slightly different. So area concept is focusing on having modeling using absolute positions and using simplified elements to do it in a simple flat structure. Whereas OpenDRIVE starts with relative coordinates and using mathematically driven approach that has definitely the advantage of having very smooth curvature, stuff like that. But on the other side can also lead to ambiguities. For example, if you have very sharp corners and wide lanes, for example. I think everybody who already has worked with OpenDRIVE knows these issues. Again, you can read through this table afterwards. What again is interesting to mention is that the area concept is focusing on facilitating the real world modeling, and due to the fact that it's just a layered approach and uses a more aerial light wave modeling, it's easier to create huge complex networks instead of OpenDRIVE, where you have to stick to some specific modeling methodologies that are incorporated in the concept of OpenDRIVE. If you can continue to the bottom of the table, then there's also again the statement regarding data complexity. So if you would like to have huge data sets, then the XML structure from OpenDrive will be an issue. If you're looking into the area concept, trying to utilize the concepts of the geoinformatic domain, then you have already tools at hand that are capable of recreating huge areas in a very detailed level. On the other hand, that's for sure. If you would like to generate synthetic data instead of using real-world data, then OpenDRIVE definitely has its advantages. Again, due to the methodology, because it gives you already some support for creating roads. And this would be a drawback if you would do it in the area concept, because you have to start, let's say, with a blank sheet of paper. And also, if we are talking about the real-time processing and simulation, then it's heavily depending on the use case. On the one hand, again, there is toolage available from the GIS domain that will support you to access data, spatial data within milliseconds. On the other hand, it could be the case that some of this data has to be pre-processed to have it available during runtime for the simulation. For example, calculating the path to travel from start to end in a complex road network. But there is an idea how to achieve this with the area concept as well. So if you can continue a little bit scrolling down in the document, there should be an image with the layers.
Yes.
Yeah,
you mean this or the overview?
Continue.
This one.
The colorful image, yes. So as I said, the idea is having a ground layer that is more or less defining the surface of the world. On top of this, there is the traffic area defining, let's say, the paved elements of our world. Then we have additionally 3 optional layers. They are referring a little bit more to the current OpenDRIVE and maybe what is needed by tool providers or by developers of specific functionality. And again, on top of this, there are the road marks and the infrastructure. Again, these layers that are definitely there because this is the build structure, infrastructure you see in real world. Not quite sure. I see at least one raising hand. Is it a question we should answer in between?
Yes, we can.
Okay, if that's possible, it's just concerning the real-time capability and also the layer concept. So whenever I got in contact with CityGML, both in flight simulation and driving simulation, well, the size of the models and the handling of the models in this PostgreSQL format always had me use the exporter from the CityDB project and ultimately use 3D exchange formats to integrate CityGML within simulation solutions. Is this a way that has been discussed already, or is it always the way of direct integration of CityGML? Because so handling and also patching and modifying CityGML is not something that is well integratable with other modeling pipelines, let's say. Are there any thoughts on that?
These are definitely topics that should be covered in the concept project we are talking here about. So the area concept itself started also to think about how to tackle with some of these basic issues. For example, how to define a suitable ground layer. for example, here it's stated tin. It could be something different. But the idea, and I think this was something Roland were just starting with the explanation. This would be one part of the concept project we are proposing here, that we also think about what would be the most suitable way to bring these data into the applications that should be use this data later on. But we currently do not have an final solution yet that we can just present, and every questions are already asked. So this is not the case.
Okay, thanks. Maybe I come back to this later on in the discussion.
Yeah, sure. It's definitely a bullet point we have to take into consideration for this project. Yeah, okay. So I think this is more or less everything important. Maybe one additional image I would like to guide you through. So please continue scrolling to the image with the short left turn lane in a roundabout. Just continue. These are just examples how this layering approach would work. Continue.
I know which one you mean. This one.
Yes, exactly this one. So one major idea we had is what I already mentioned, is we try to model what is there instead of trying to add synthetic information, let's call it that way. And the application should be able to process this data. Because in general, we have automated driving, then this self-driving system has to be able to handle reality as it is. On the other hand, it's absolutely right in this discussion that some data has to be pre-processed because if we only have the real world ready, then I need simulation models that are already able to drive on their own to be able to develop self-driving systems. And this is definitely not the case. So that's why the area concept suggested to have at least the lanes and the paths, for example, as additional layer, because if you get the data from a public authority that maybe has cadastral data, including curbs and infrastructure and stuff like that, but does not incorporate information about lanes, then you could at least use this data and then start the post-processing on your side to come up with lanes and maybe add suitable path for your traffic agents as well, and can add this to this data set you got from third party. And could also distribute this to the simulation tools that may need this information. But the advantage here is, or the idea behind this is that we do make these more specific information that are of interest from the automotive domain only optional, because we would narrow the number of sources for getting the data. If we would say to every public authority, if you would like to provide your road layout from your city in this format, but you have to provide also paths and lanes and stuff like that, then it could be the case that they have to drop out because they do not have the manpower to provide the data in this detailing, or maybe are not interested in spending money for a contractor to doing so, because for their application, they don't need any lane information. Yeah, so this is more or less the idea of the traffic area concept. using points, lines, and surfaces in 3D world and try to model everything you can see outside and everything else you are interested in, using the possibility to link to additional layers you can incorporate, or maybe link to additional data sources so that you can include environmental information as well. And the discussion, as I said in the beginning, were finalized in mid of 2020, I think. Then it was put into the backlog of suitable ideas. But now the discussion more or less comes back because what I have stated in the beginning, the need of having more complex data, more real-world data into simulation, it's still a need, at least in the automotive domain. And the need is still growing regarding the development of the of self-driving systems, for example. And due to the fact that CityGML is a very promising candidate for providing the environmental information about infrastructure, vegetation, buildings, and stuff like that, we come up in a smaller group of people with the idea maybe to create again a project that will have a look into the different formats we currently have a look into possible requirements all the stakeholders here in this meeting will have, and analyze what could be the most suitable way to compete with these challenges. I think this already leads to the next agenda topic.
Yes, perfect. Thank you very much. I think now we should jump to the presentation of the proposal and the intended goal of the project. And what Roland said before is that the goal is definitely to have a concept project, I think. And Andreas, you repeated that, so that we can evaluate what is possible and how should we approach that on getting the most out of CityGML and OpenDRIVE to satisfy the use cases that we see. Roland, do you want to take over to present
additional questions?
Yeah, plus obviously, yeah.
You want to take over again?
Yes, I can take over again. So I tried to summarize what we in the small group, what our ideas were. So now we heard basically 3 different modeling approaches of modeling the road space and partly also the environment. So, and as Andreas mentioned, there are different use cases. Currently, those use cases are covered more or less by the different approaches. And as Andreas already stated in this proposal paper, we have several goals, and maybe I tried to summarize those goals here. So the possible outcome of this proposal, of this concept project, the outcome can be, there are different possibilities of the outcome of this project. And we can follow different roads, different branches. So one possibility would be to have a look in how we can connect the already existing standards of OpenDRIVE 1.x and CityGML standards. So how we can link those both worlds, which of course will lead to issues. We have to think about if those problems which will arise can be solved, if this makes sense to link those both worlds. So this is one issue we want to have a look into. The second is maybe it's not possible to link the current OpenDRIVE standard with CityGML, but maybe we can adapt OpenDRIVE, maybe a version 2.x, and the current CityGML, or also maybe we need to adapt CityGML as well. And we can therefore make proposals what would be needed to cover all our requirements for street space modeling and environment modeling. And this point could lead to that we might get rid of some of the known issues of OpenDRIVE, and we maybe we could remove some elements of OpenDRIVE. For example, currently it's you can already in OpenDRIVE model all some environment objects in a cumbersome way. So maybe you could replace those possibilities of modeling the environment in OpenDRIVE by other formats as CityGML or other concepts. A third possibility we could have a look into in this proposal project is if we could extend the existing CityGML concepts with concepts from the presented area concept. So as Christoph presented, this transportation module of CityGML was revised, but it might still not meet all the requirements of the simulation domain. And maybe we can link the ideas of the area concept and with the approaches of the CityGML standard, and maybe we can create an application domain extension for CityGML covering all the needs of an automotive application. And a fourth possibility, if we end up with the conclusion that all the existing standards do not solve our requirements, and maybe we need to go on a different path, then it might also be a possibility to follow up the area concept and create here a distinct ASAM standard. So those are four approaches we like to think about in this proposal. We will have to see what the real outcome of this proposal will be. I think further on we have some here we have some table on our work packages, so on the roadmap on how we want to start this concept project. So first of all, we want to get a common understanding. So we want to have a more detailed look in the three existing standards or in the existing concepts. And then we want to summarize all the requirements for street space and environment modeling, and gather those in a list. And then we will have to think about those requirements and think about how we can solve this, which of the stated branches we might follow to solve the issues. And so that's the basic idea. This proposal paper is still work in progress. but that's the ideas we collected so far.
Maybe one point in addition. The idea is in general to think about a new solution, and the best way would be if we can reuse already existing concepts. So that's why the analysis of the current standards is quite useful. The goal is not to stop the development of one or another format because they are already established in their domain. And as I said, they also do have their advantages. We are focusing on the use cases where these formats are currently struggling and try to solve them. So every format on its own, I assume, will continue. And we try to find a bridge, bringing them closer together. Or if we do not find a suitable solution where we only have to add something small to either one or to another format, then maybe we have to agree to go the path to create something new. That would also lead to the situation that tool provider have to improve their tools in a more broader way instead of just adding a small extension. And also the data providers have to invest more effort because they have to create first data in the new format. But this is the large variety of outcomes that this project could have. And we are currently here at the point where we have to decide which way is the most suitable one for all the requirements we would have here. So that's why it would be quite good to have in this project a large variety of stakeholders. So not only simulation users, not only tool providers, not only data providers, but also people who are let's say close to the needs here, for example, public authorities, so that we can get a good overview about what is needed, where we should take care about, but maybe also which requirement maybe is less important because there's no such huge need to cover this as well, and incorporate this here into a requirement list, come up with a solution list, and then at the end having concept proposal document that again can be discussed and agreed on by the technical steering committee, and building on top of this, the solution will be implemented independently what kind of solution this will be.
All right, perfect. So
have a look at this time schedule.
I don't know if we have.
Okay. No, that's okay then.
No, okay.
So
that's fine.
We haven't.
This is all still up for discussion. So if we look on the time schedule, how and when we need to approve the project and what still we can do until then. So we have to put in the project proposal in the April TSC. So until then we can approve the project and people can get their input in. And we can establish on how long that project shall run and what the content of that project shall be. Yes. So did this sort of answer your question?
Yes, it does.
Okay. So to recapture what Andrea said, is the goal of the project is to evaluate how to get the best out of two worlds and to solve the use cases that are not covered with the already implemented and well-established concepts. we had the question before, and Ludwig, you're here now. So, would you see a way on including the open material project in this overall concept as well?
Well, it is certainly a third domain that I see besides the data provided by CityGML and the road data from or the road network data provided by OpenDRIVE. What I tried to point out in my last statement is that right now, or at least from my experience with CityGML, it's on a slightly different granularity than OpenDRIVE or 3D models used in driving simulation. So from the LODs that are provided by the measurement companies or by the state agencies here in Germany, it's more like a LOD1 to LOD buildings. That means buildings with properly with proper roofs on them. It's basically the plan view, the extruded plan view of the buildings and a proper roof of them, which is quite usable for flight simulation, for example. But for driving simulation and the annotation of materials, I see a little gap here. So concerning the granularity. And this is why I was always a great fan of the export functionality of the City 3D project that I used to export certain regions to GLTF format, for example. And then we are on a granularity level where I would assign material properties, where actually 3D modelers are working and refining models. So maybe there's some meta level required on for example on the base of GLTF, where materials can be assigned, where more fine detailed buildings can be, and also whatever there is other infrastructure can be refined within CityGML. So material, I would neither assign materials directly to CityGML or OpenDRIVE, but to a proper 3D file 3D exchange format. And in my opinion, the most promising candidate here is GLTF.
So, but the problem with this is then you're already stick to a data format. So perhaps we have to clarify that CityGML is no data format. It's more like an ontology of how to describe objects in the city. So, and I think, or I really recommend to not stick to any real data format like GLTF, because GLTF has no semantics, or at least just the basic semantic that, for example, a polygon knows I'm a polygon, but there is no semantic. Is it a roof or is it a window, a door? And without
for plain GLTF,
semantic,
this is for plain GLTF, this is right. But we also introduced model structure specifications in Open Material, and this is also our experience from other publicly founded projects, that for certain object classes, model structure specifications have to create it, for example, that allow animation of pedestrians, vehicles, and so on. Again, this is on a very rather detailed level. Right now, I wouldn't see it, or I have not stumbled upon CityGML models that were that detailed. I saw some of them with properly modeled facades, for example, but the structure or the structure was not in a detail level where I could distinguish, let's say, the wooden framing from the glass in the windows.
So in general, CityGML is able to represent this, of course. So because CityGML covers really, really detailed models by the standard itself. So I think the problem, what everybody is asking for, more detailed model covering the whole world. So, but this is the problem. How do you model these? You can hire some an army of modelers, and they will model the world in a real big deep detail. But
yeah,
so currently, if we want to have a coverage, or we have to live with the data we have. So I agree on a use case where you have a specific road where you want to test something, then you can model this. But if you want to move your approach to, for example, a city in the city of Vienna, or where you don't have it, then
you don't have to convince me here. I definitely see the purpose in CityGML. Yeah, but again, I see also the use case of driving simulation where the observer is pretty close to the buildings. And also those buildings, because I'm always about why I'm talking about 3D models here. 3D models in driving, flight simulation, whatever, are not only the static models describing the infrastructure, the buildings and roads, it's also the vehicles, pedestrians.
Yeah.
And we have to find some consistency here. So I am rather with the 3D models and defining structure here, achieving consistency between for material description here, rather than having a material description just for the road or just for buildings, because it will not be consistent, and I will never be able to establish proper material databases for that very restrictive use case. I have to achieve consistency, otherwise I cannot use those models in the wide variety of sensor models that I'm confronted with.
Yeah, but a solution could be like something, an OpenDRIVE extension mechanism. So this is why we introduced this mechanism, because in the beginning of CityGML, we talked with many people who are interested in 3D models, and everybody says, but I need this specific material property, I need this structure to work with my tools, and so on. And the problem is to bring all together, even I would say in the automotive domain, so where we think we have a common understanding of things. Even in this domain, when I talk to people, everybody has a different understanding of materials. So
You're
what I
right.
think is the issue is how much standard do you, or how much do you standardize that will cover most domains, and how much not? And this is why we introduced this application domain extension. This means that, for example, you are in the driving simulation and not in the traffic simulation, then use your extension and describe your things there.
Still, I do not see material description in the vicinity of OpenDRIVE, because it will be restricted to the road network description. And I have materials as set for the dynamic content of the virtual world as well. And therefore, and yeah, exactly right, there's a wide variety of requirements from simulation tool vendors, from sensor modelers, from OEMs. This is why we created Open Material, where we are discussing the specifications for model structure and also the set of parameters required for rendering and physical sensor simulation. And we have contributors and also users from different publicly founded models, from simulation tool vendors to sensor modelers, and they all bring in their requirements and their required parameters for their models. Of course, they do not outline their model structure, but at least, or it's, for example, for the radar use case, there are some values that are widely used, also for measurements at universities, for example. And if we were able to create a set of parameters that can be used or is usable by the automotive industry, of course, then we can use this parameter set and annotate it to whatever we want, be it a CityGML or a GLTF for 3D models, but also an OpenDRIVE. I just would not see the development of this or the definition of this parameter set within a single project. I think that's the wrong way.
I completely agree. Yeah, I completely agree. So this is, because this is a topic that covers many people, as I said. This is something that should be, not only in one project, of course.
Exactly. And this is also, so I was working on the problem of creation of model and material databases several times, and there's the approach of creating the database first and then realizing that there are models that are of different type, of different structure, of different origin, and in the end they cannot be handled anymore, even within one company. But I think to have, as you started, if we want to achieve a scalability and also measurement of the whole world, we have to come to a common approach. And a common approach in this case is a common file format, whatever it is, how we want to store our data, and then different parties can contribute, data can be exchanged, and so on and so forth.
Yeah, but this is exactly the point what I meant with not in file format, but an ontology. So what we don't need is a file format, because this sticks us to implementations of this, but more common language. I always say ontology. It's so, because when I have a common language how to describe the structure, then I can say, okay, I make my Postgres implementation of my material database, and it really conforms to the common model of materials.
Yeah, we have been developing Open Materials as an extension to GLTF because it was the openest extendable file format that is also widely used and has backup and is applicable in most of the game engines, in the modeling tools, and so on. So you have to have a look at the existing processes as well. And in this case, so if you want to get many people to the same table, you have to have at least some format to convey your ideas and to make them usable and make experienceable. And then, of course, you can also still step on to other formats, use the semantics you developed as we did in this extensions, and convey them to other formats. But I think in order to get some people to the same table, we need such a format at the moment.
So I think that is something we definitely can put in the concept project as a task to evaluate and see how would we develop that. Andreas, you have your hand up.
Yeah, I just wanted to add that one discussion we had in the area concept was also the idea of being able to link to additional data sources because it's unrealistic that we come up with a world modeling format. And I would say this applies for this discussion here as well. So there is definitely the need to be able to link to additional databases or data sources to get information, for example, about the material. I think this is a part we should consider in the project as well. And it's also absolutely right that we have to take care about already used approaches. For example, when we discuss the surface model in the area concept, we also had the discussion how we can make sure that every tool provider is interpreting the data in the same way. And for this, it makes sense to have tooling available where you can just refer to. And in this case, referring to open material, for example, could be a solution. And we have to make sure that there is a possibility to link from one format. So, for example, from our solution to the open material solution, so that the tools that are interested in this data can get to this using the links that are incorporated in the format.
Okay. So are there other opinions on if it makes sense that we try to evaluate how we could benefit from the advantages of OpenDRIVE and CityGML? Or how that could look like, and that it makes sense to evaluate that. So obviously we've got the people that wrote the proposal that are behind that idea, but we have quite a few other people here in the call. So maybe we have a few other opinions we can throw into the discussion as well. So there was or is quite a discussion going on in the in the chat. So maybe Marius, you can share your point of view to that topic. Just to call you out now, sorry.
So is it working now? Sorry.
Yes.
I forgot how to unmute. Anyway. Well, yeah, no, it's you have seen most of the stuff in the chat, and I think some things were clarifications that were done today, which is good. So I think we should all be on the same page, more or less. What I just see, and this is a question to the guys from CityGML. So it's always described, it's extendable, and you can have these domain-specific extensions, etc., etc. So and then I understand that this link to OpenDrive is sort of in the same direction. So this needs to, you need to make sure that this is managed in a way that there are, for similar use cases, you are always using the same kind of definitions. And so my big fear would be, if it was not managed properly, that there would be different implementations for the same stuff. And I think this is what needs to be avoided. And therefore, I think it's a good idea to have this concept project here to see how OpenDrive and CityGML can be linked, and whether this can serve as a blueprint for other extensions. But I'm also, of course, with Ludwig, what he's mentioning in terms of the details of modeling, and there needs to be a definition where materials have to be located. And if CityGML is just the aggregation of definitions, then you need at least to make a recommendation which other formats to use in connection with let's say, the reference in CityGML. Why all of this? There's a user base. There is today a user base for OpenDrive. There will be a user base for OpenMaterial. There will be user bases for CityGML and so on. And you need to make sure that people who are trusting in what you're trying to build here, they are not disappointed by, which means if they trust what you're doing here, they will build assets based on this. So they will invest money, they might change their tools, they might adapt the tools, they might buy tools that are compliant with what you're proposing here. And then they will build a lot of data based on that. And this data needs to be preserved. And I think this is what needs to be kept here in mind when you think about how you make things interoperable. But that's just my humble opinion on all of that. Anyway, go ahead. It's a good thing, and I'd like to see the outcome.
Okay, as we are in the proposal workshop, would you like to attend the project as well?
I'll follow the project and join a meeting here and there. No, yeah, we can discuss it, Nico. I think we should have a direct conversation about that.
Yeah. All right, because having a lot of people in there with a strong background in the individual standards will definitely help drive the project forward and to a good result. And Marius, I know that you have quite a good background in OpenDrive.
Thank you. Yeah, sure. Okay.
Nico, so you can also write down my name on behalf of BMW. I'll have to check back as always if my boss allows me to join, but I will happily join the discussion. And as said, I have some experience with all of the standards, and I think there's a very promising approach. We just have to lead it in the right direction.
Perfect. As we are,
will also take part.
Awesome. I actually didn't intend to jump into the commitments right now, who wants to take part, but as we are already there, the more supporters we get for the project, the better. So we have the proposal team anyway with Virtual City Systems, Volkswagen, the TU Munich. I guess you guys will stay with the project. So who else would like to join that project? So we've got
Frank Wilstein from Rheinmetall.
Yes.
So I have also to double check it in the company if we take if we participate in this project. I like it very much, of course, and would like to continue the work.
Awesome. So thank you, Frank. Thank you, Andre. So I've wrote you down as well. So then I've got Hugo back. You would need to let me know what company you are from. And then we need to see, because for the participation in the project, in the end, the ASAM membership is required. So if there are any questions too with that, we can just have a chat afterwards. Okay, then Daniel from Perfect. Thank you, Daniel. Thank you, Hugo, for the company name.
Yeah, so I will double check with Philip on that. It will probably even not be me that will participate because I'm already tied up in the development project.
Yeah.
So for CityGML, we have Teresa, who knows much more about CityGML, and yeah,
Perfect.
We will get back.
Yeah, if we get an even split between experts from OpenDRIVE and CityGML, I think that will definitely help. All right. So don't worry if you don't know yet if you would like to join the project. We will open the enrollment for the project itself after the proposal workshop. So there will be the opportunity to enroll to the project anyway via the website. So what would be the next steps? So definitely, I think all the people that already now raised their hand and know that they want to join the project. And then obviously, once you have the confirmation from your company, we would need to finalize the project proposal with all the discussions or based on the discussions we had today. And then we can have another workshop with all the people that enrolled to confirm the contents of that proposal, and then we can push this forward to the TC in April. And yeah, with that we then hopefully can start the project. So what we said before is that this is going to be a concept project. So the outcome of the concept project, just to recapture that for everyone who has not joined a ASAM concept project yet, is not a standard, but it's a concept paper or white paper, if you like, that explains a certain concept and is there to evaluate possibilities. And then we can decide, okay, is that enough having that concept paper so people can, based on the concept paper, develop an API or whatever? Or do we need actually a standardization project, or do we hand over the concept to another standardization organization like the OGC to implement it in their standard or whatever? So this is all open, and we can define that for us. And then we can see whatever fits our needs best. So maybe towards Andreas, Roland, and Christoph, did you already had a runtime of the project in mind?
To be honest, no. It depends a little bit on how many participants we will get and how suitable will be the collection of requirements and the analysis of possible solutions. So if we only have some experts there that can really commit themselves to spend time on doing the research and bringing together the input we get from all the participants, then maybe we can speed up this project. But to be honest, I think everybody of us here has additional work to do. And I do not want to last this longer as it needs, but I think sometimes the having a little bit more time then just doing this in a hurry would be suitable. So in my opinion, my proposal would be to not have a shorter project than half of a year.
So half a year is quite short from the experience. So I would, from experience, recommend at least a year for the discussions, because as most of you will do this as a side hustle and not doing this as a full-time job. So this
summer
is definitely
vacation will strike us.
Exactly, summer vacation
will strike us.
Exactly. So a year is shorter than we think. So I would recommend having at least a year time, especially with all the things that are going on, and as many of us are really, really busy with online meetings. Yeah. So if there are no objections, that is something we can take down 12 months. And if we see during the project, okay, we don't need that 12 month, we can either have an extended review phase and put it out to the industry what we think of and gather their feedback, and then maybe even have a better concept in the end. Or if we need more time and we see that we need more time, then we can request that time from the TC. Now, in terms of organization, we need one member to submit the proposal and be the main driver of the proposal. So Andreas, you were the one in the past who drove that thing. May I write you down for that one again?
For the current phase, it's absolutely
yes, until
okay
the
for
TC.
doing this. Yeah, and I think within the whole group that will compile this document, then maybe we will also have the discussion about, if we get green light, how we can continue with that.
Exactly. So as Dorothy presented in the very beginning, that it is possible to lead a project and that the project leader will be elected on the first meeting of a running project. And I know that Ludwig, you've led a ASAM project before, and Esther, you're doing it right now. So maybe you can share one or two sentences on how is it like to be a project leader at ASAM.
So
Ludwig,
you want to go first? So, well, it's basically taking care that the project plan is achieved, and sometimes pushing people a little to to complete tasks, to put it friendly. No, it's usually a very interesting time, very interesting talks, but the project lead has to take care that in the end either a proposal or a standard is created as the output of the project, and yeah, this is the time mostly towards the end of the project where the project lead might also get some a little bit busy to just keep his team aligned and focused on finishing the document. This is the most demanding task, probably.
The good thing is that we get very good support from ASAM, from the writing the documentation itself. So we do not have to really write the document ourselves. This is done by a service provider, so that helps a lot. But as a project lead, you will then have discussions with the service provider, etc., to make sure that they are on track, etc. So it's a little bit additional work compared to if you are just a normal, in quotes, member of the project.
Okay, thank you very much. So maybe someone from the group wants to volunteer and fill that position. Because
yes, so Nico, you can keep it short. So we talked with Stefan and I talked to Roland, and we would like to take over this position. And I think because we have real good knowledge of CityGML, of course, and of OpenDRIVE. So I think we can cover or know at least all the ideas for both domains.
Awesome. So, Max, that would be you then, or would that be Roland?
I think we have to talk bilateral on this.
Okay. Then I will just put down project lead candidate as Virtual City Systems.
Yeah.
Awesome. Great.
Cool. Thanks.
Never had that issue solved on the proposal workshop, so that's new. Awesome. Perfect. Are there remaining questions from the audience towards how the process is, about the content? Anything else we need to clarify today?
In order to check if we participate, is there a minimum amount of contribution expected? Do we already have a figure of that? Yeah,
that would be my question too.
That is a very good question, and I don't have the answer to that. So maybe Andreas or Max, Roland, did you have anything in mind?
Not yet. So as far as I know, the group who are participating, most of you is, so we'll spend time on this. So any help is welcome.
Yeah.
So Frank, of course, if you don't have much time, but I know you know CityGML really good and have a long knowledge of the history of CityGML. So it would be really cool if you participate, even if it's just 5 or 10 days or hours, whatever.
I think, definitely anything helps. So if we say the project starts and we have maybe one meeting every 2 weeks, that runs for like 2 hours if we stay with online meetings. That could add up to like 10-15 days a year. Or if we maybe sometime in the future have face-to-face meetings again, then I would recommend having the proven cycle of 8 weeks and then 1 or 2 day meetings face-to-face, which then probably would add up to a similar amount. What we then definitely would need to add to those 10-15 days is the amount of time you would need to spend to do homework. So if we say like 20 days over a year, 15-20 days over a year, I think that's a reasonable commitment where we can definitely push something forward. If someone is not capable of providing that much, I think we do definitely anything will help. So is 20 days something where you would say, okay, that's your recommended amount and that's something you can go with?
Yeah, of course.
Yeah, makes sense.
Awesome. Great. Further questions? Awesome. Then thanks everyone for joining. Even though we had some technical issues in the middle, PowerPoint didn't like me too well. I think we solved it really good and we've got a way forward. We've got a team together already. That is all really awesome. And I'm really looking forward to what the outcome of that project will be.
Thanks very much.
Have a great, have a great evening. Thanks, everyone.
Thanks.
Thank you very much.
Bye-bye.
Thank you very much. Bye-bye.
Thank you. Bye.
See you. Bye-bye.
See you.